So I'm Brendan from AWS. Paolo is actually going to be speaking about Nextflow and the workflow tool that's working on top of AWS Batch. Batch is Dockerized, a Docker container-oriented service that we run. Very similar to Magnum. I can see an awful lot of common characteristics there. On a container note, back at our conference, our user group conference at reInvent back in November, we announced some 60 new things. One of them was Kubernetes management and Kubernetes support for our Docker container environment. So if you're interested in Kubernetes, and I think most of this community is, I would commend you to go and have a look at the announcements there and have a look at the new tech and the new service that we built around it. But with that said, I'm going to shut up and get out of the way and hand it over to Paolo Di Tommaso.
Okay.
Thanks, Paolo.
Welcome. So hello. I'm going to talk a bit about our experience using AWS Batch, the other AWS Batch service in the cloud with Nextflow. A few words about me. I'm Paolo Di Tommaso, a research software engineer in the Center for Genomic Regulation in Barcelona. I'm also the author of Nextflow, this pipeline framework that I'm going to introduce in this talk. So I work mainly in developing, deploying genomic workflow. I think most of you know very well this kind of application, but just to put in the context, these are data analysis applications that extract biological information from large data sets. We are talking about from, let's say, from a few gigabytes to some terabytes for rounds. So there are something heavy to manage, and you need to speed up your computation different way. That the most common approach in this kind of application, having an embarrassing parallelization approach, you just split your data input source in many chunks, and you execute in a distributed cluster in a very easy manner. And most of the time, these applications are just mashed up different tools that are put together in a big bash script or a different scripting language like Python. And so then, because the main point to have an easy way to prototype this application in a quick manner, but the side effect that these applications tend to be very fragile, complex to maintain, because a big dependency tree are difficult to configure and so on. So let's see how AWS Batch can help to tackle this problem to run this application. This is a new service that has been introduced, I think, more or less 1 year ago. Provides the ability to run compute jobs in the Amazon cloud in a batch fashion. So it means that in a synchronous manner, you launch a bunch of jobs, and after a while, the infrastructure compute these jobs for you. You can fetch the result. The very nice part of the service that everything is managed. Actually, you can choose if you want a managed application or managed application. This way, the service takes care of speed and scale the instances to run your workload. It provides the concept queue like in a traditional batch scheduler. So you can bind some tasks to a specific queue that provides a specific kind of resources for your workload. And then the very next part, that a job is basically a container, Docker container that can run your task. So in practice, what does it mean? That you have a script that looks like this. There is a prologue in which you have to download your data from the remote storage to the container, because the container is a transient it's a transient work unit. So you have to download the data, run your task, for example, just BWA, whatever you want to execute. At the end, you have to upload back your result into the object storage for each task. Basically, what you have to do, you have to reduce your task to creation of Docker image, where you include your script, all your tools that are needed to run this task, upload in a public registry, create a queue and a job definition in AWS Batch dashboard, and then you can run this task or many other tasks using the AWS dashboard, the command line tools. So far so good, but imagine to run a big pipeline like this. This is the companion genome annotation pipeline, but it's not just the pipeline, but to give you the idea of real-world application. So if I want to run strange bits like this, using that approach can be difficult because I should create a specific task to download the files, to run the job, and then upload back and the result for each of these steps. There are something like 70 different steps, so it can be a bit difficult. Also, this makes difficult to make this pipeline portable, because once I wrote all that wrapper for AWS, the S3 storage can be difficult to run in a different infrastructure, or just to test this pipeline execution on my local machine where I may have developed my pipeline. Also, ideally, we would like to use what? Custom container images. There are a huge collection of tools already provided by the community. Instead, using this approach, I need to modify the container to include my script. So here we come to Nextflow, to this pipeline framework that we develop at CRG. It's a tool that tries to put together different aspects in the development and the deployment of pipeline. The orchestration, the parallelization of your pipeline, providing a DSL, domain-specific language that allows you to simplify the parallelization of the workflow with the scalability and the portability, the meaning that it provides you a way to write your workflow once and run many different computation infrastructure using batch scheduler like Slar, Green Engine, etc., or using AWS Batch or different approaches. And finally, the built-in support for the containers. That means that Nextflow takes care to containerize your task using different container engine. It can be Docker, Singularity, even Shifter. This allows you to abstract your workflow from the target execution platform. So, just to see in practice, does it work? Imagine that we want to run the same task like before. What we have to do is to wrap this task in this process definition, which I define what are the inputs. I just say that I need two files that are taken from this data structure that we call channels. Then you have the output, one or more output or different data structure depending what is doing your real task. And then there is the final task. So in this way, we have a clear definition, kind of interface my task with some metadata that allows me, the tool, to run this task in different computation environment. Portability. So this was one topic of this session. I can run this script using the Nextflow runtime in a single machine like this, but I can switch easily to another computing environment, maybe a Slar cluster with Singularity, just providing a configuration file like this, in which I say I want to use Slar like an executor, and then maybe the computing results is like the queue, the memory, the CPU, and also eventually also the container. Providing this information, the runtime will generate the wrapper to run this stuff into a Slar cluster with Singularity. But what if I want to run with Batch? I just need to say that I want to use the AWS Batch executor. Then this same information are reused, applied in the context of Batch. This looks nice. Let me give you just a very quick demo to give you a better idea. Does it work in practice? Well, very big screen, cool. Here okay, let's say that I want to run this pipeline. This is the skeleton of a RNA-seq pipeline that I uploaded on GitHub. There are a few files, and this is a very small data set that just I'm using to run this pipeline. Nextflow, this is multi-QC configuration file, the usual Docker ignore, git ignore files. The important file is this one, the main pipeline script. If I scroll down to the interesting part, you can see here there are the process that we were saying before, just a process to execute, to run, to generate the genome index using Salmon. Here there is a command line, then there is another process another step to run the quantification of my samples, always using the Salmon tool. Then the fast queue to perform the quality check on the samples. Finally, there is 4 steps that run the multi-QC. That is a tool that aggregate the final result in a beautiful report. Nice. If I want to run, I could clone this project locally, or and run with Nextflow, or more easy, in a more easy way, I can just take the Nextflow command line tool and say run the project name. What is going to happen? The Nextflow pull the pipeline, launch the execution using the data that was included in my project repository. You see that try to execute 3 tasks, the index, fast QC, etc. Then okay, here stops. This is an error, but because I wanted to show you what is going to happen, then what is going to happen that I don't have Salmon installed on my machine, command not found, but I have the ability to run the same command using a Docker container that I created to run this stuff. I can say with Docker Nextflow RNA seq enough, and by doing that, the pipeline task run using this container, and you can see that it's running smoothly. Okay. Maybe. Here it is. We have the report. Okay, obviously it was very, very small data set, but just to give you an idea how does it work in practice. So now, what if you want to run these things with, now we run this computer with Batch in a cloud service. Oh, I have this configuration file that is more or less what I was telling you before. Where it is? Oops. The executor batch, then I specify a queue demo, that the container is the same like before. Then I have to specify the word here S3 bucket where all temporary data is uploaded and downloaded. That's all. Okay, there is also the path for the AWS3 command. So having this basic information, I can just switch here, come back and try to execute, specify this configuration file. Here it is. You see that now it's running with Batch. It's submitting the task in the Batch infrastructure. If I go here, I should find the jobs. Demo. Enable. Okay, this will take some time to spin the virtual machine, etc. But the beauty thing that just changing a small configuration file, I can instruct my tool to run this stuff in a completely different environment. So without struggling creating wrapper files, etc. So I think running out of time, few minutes to close. We run a benchmark with a real data set using a pipeline very similar to the one that I showed you. We run this quantification pipeline using 370 human samples taken from the ENCODE project. The pipeline executed 750 jobs using 65 i3 large spot instances, taking more or less 23 hours. And this is a timeline. This is too big to show it, but it gives you an idea of how many tasks were executed. If you zoom, you can see that each line represents a job that was executed by this pipeline execution. Then here there is another chart that shows the distribution on the jobs. I finished the time. Just a consideration about the business. This is very important when you run stuff in the cloud. We spent to run this pipeline $310. That's more or less $1.2 per sample. Not so bad, but actually I was expecting a bit less. And when I look in the details of the cost, it turns out that each urgent it costed $90 only for the computation for the spot instances. So where the other money come from? From the storage. Actually, it costs $220 for the ABS storage for the ABS storage, because actually this was my mistake, because I used 1 terabyte ABS disk for each spot instance, that actually you don't need all this space. Using a better sized volume, let's say 200 gigabyte, the cost was reduced to $135, so that is more or less $0.36 per sample. Is fair enough price. Okay, I think running out of my time. This is just another use case that Science Life Lab. There is a big user of Nextflow. They have a number of pipeline production between this and NGI RNA-seq pipeline, and the cancer analysis workflow. Last slide, just to say thanks to my colleague Evan Floden, Emilio Colombo at Notre Dame, and obviously Phil Levels at Science Life Lab, and Brendan for giving me the opportunity to present this work to this audience. Thank you.